Right, so let's start. If anyone who is comfortable in turning their cameras on, please go ahead. It will just make the introduction better. So, hi guys, this is me, Rishi Maheshwari. All right, so now let's start off. So, very good morning to everyone. My name is Rishi Maheshwari, and I'm a second year student of mechanical engineering. Today, me and my friend Ashu Gupta would be explaining SolidWorks to you all. And later on, after the presentation, we would be making a live model that is a gear and a shaft, which would help you in understanding SolidWorks to an altogether decent level. Right. So what we would be going through in this particular presentation is that we'll start off with the boring part, which happens in every single presentation, that is the introduction. So it's pretty mainstream, and we would be telling you about SolidWorks, its developers, where it's chosen, its advantages, etc. And after that, we would move on to the more technical part. So where we would be explaining the most important and basic tools which one uses when one starts off with their SolidWorks journey. So after that, there are some advanced features like surface modeling, sheet metal, and the most important part of SolidWorks, which is the assembly. And later towards the end, we would be telling you about how the 2D drawings are made out of the 3D sketches. And we would end the whole presentation with making a live model right in front of you to give you a better understanding. So now my friend Ashu Gupta would be taking on from here in the presentation. Ashu, it's all yours.
Yeah, thank you, Rishi. Hello, guys. Myself Ashu Gupta. I'm currently studying in second year mechanical branch, and I'm your mentor at IEEE DTU. और थोड़ा सा मतलब जो पार्ट होगा ना, या जो स्टार्टिंग वाला पार्ट होगा, थोड़ा सा बोरिंग लगेगा तुम्हें, बट लास्ट में हम तुम्हें पूरा पूरा एक मॉडल दिखाएंगे, लाइव मॉडल, जहाँ पे तुम्हारा इंटरेस्ट बिल्ड होना स्टार्ट हो जाएगा, और लास्ट तक देखना. और लास्ट में हमने तुम्हारे लिए एक काउट रखा है, और जो जो उसमें विनर्स आएंगे फर्स्ट सेकंड पोजीशन थर्ड पोजीशन, उनको हम स्वैग वगैरह देंगे. ओके, so now we start with the introduction of SolidWorks. So SolidWorks is a solid modeling CAD computer program. तो CAD क्या होता है ना, CAD basically computer aided designing, and it is published by the Dassault system. SolidWorks is used to develop mechatronic systems from beginning to end. At the initial stage, the software is used for planning, visualization, modeling, feasibility assessment, prototyping, and project management. The software is then used for the design and building of mechanical, electrical, and software elements. SolidWorks Corporation was founded in December 1993 by MIT graduate, and according to publisher, over 3.5 million licenses have been sold to date to engineers, designers, and company as of 2021. Now, in the next slide, I will tell you about the Dassault system. So, Dassault system is a multinational software company that specializes in 3D design and product lifecycle management, PLM software. The company is best known for its flagship product, CATIA and SolidWorks. Dassault Group created in 1981 by Aviance Marcel Dassault to develop a new generation of computer-aided. In 1997, SolidWorks was acquired by Dassault Systems, a developer of mechanical design solutions. Now, in the following slide, I will tell you about the advantages of choosing the SolidWorks. Why is SolidWorks the best? SolidWorks have many benefits, like the one of the most popular CAD platform today is SolidWorks, because it has a user-friendly GUI, having a quick to understand features and utilize them for design development. Shorter learning curve as compared to other leading CAD tool in the market, and also there is a parametric and direct modeling capabilities. And also there is a feature in the SolidWorks smart dimensioning. Like when we made any part, we want to give a dimension to that part. So we can give a dimension by the help of a smart dimensioning feature in solve which is provided in the SolidWorks, and you will know about that feature in our SIGs. And also, okay, okay.
Yeah, go ahead, go ahead.
Okay. And also in the SolidWorks, we have a we when we have a more number of parts, and we have to check that there is an interference or not. Then we check by the help of a assembly feature which is provided in SolidWorks. Now these are the other commercial software like Creo, Autodesk Inventor, Dassault CATIA, Autodesk Fusion 360, Autodesk AutoCAD, and open source parametric 3D CAD software, which is known as the FreeCAD, and it is easily available on an internet, and you can use it without downloading on the system. Now, I will tell you about the importance of CAD models in manufacturing. 3D computer aided design CAD files are integral to today's manufacturing process. On the surface, the idea is sound. An engineering team will design a part and in turn will send the necessary 3D CAD file to the manufacturer to produce the part. There's an expectation that the design to the manufacturing process is seamless, which should, as a consequence, help all parties cost and accelerate time to market. However, the reality is far from perfect. Common to most process is the bottleneck of error and inaccuracy in 3D CAD data when one format is read in another CAD suite. And also, during the 1960s, CAD was eventually developed for the purpose of designing automobiles. After great success, the technology spread to other sectors in the manufacturing industry and soon reached the electronics and aerospace industry. Now, I will give examples of CAD from basic to advanced. This one is nut and bolt, and second one is a Oldham coupling, and third one is a four-jaw chuck, and the last one is a design and assembly of Audi R8. And from the next slide, my friend Rishi Maheshwari will continue.
Right, so now moving on to the more technical part of SolidWorks, this is where the fun begins. So now telling you about what features and parts actually are. These are the basic building blocks of any SolidWorks assembly. So as you can see right down on the three pictures, the first one is a clamp, the second one is a shaft, and the third one is a lathe machine wheel. So all these three are very small parts of a much bigger assembly altogether. And towards the end, in the assembly part, we would be showing you how these parts actually come into use when we are going ahead and making an assembly. Right, so coming on to the command manager, etc., we'll tell you about the features and the SolidWorks feature toolbar, which you would be using. So the command manager basically focuses on the 2D part of your SolidWorks assembly. And the SolidWorks feature toolbar is actually used to convert that particular 2D sketch into a 3D object. So, right, let's tell you about the command manager. So, this consists of the features which you will use when you start off any part in SolidWorks. So, as you can see that there is a line, there is a circle, polyline, you can see a rectangle, arc. All of these are actually used to make your 2D sketches on which you would actually experiment and then convert it into a 3D entity. Right down there is the SolidWorks feature toolbar. As you can see that there are many functions like extrude boss base, extruded cut, hole wizard, revolve cut, etc. These are all used to convert your 2D sketches into 3D objects. Now, from the next slide onwards, there are three slides containing three feature toolbar tabs each. And I would be telling you each one of these in detail on the software itself. Right, let's start on with the extrude boss base, revolve boss base, and swift boss base. So what these actually do is, the extrude boss base is the most used feature in the whole SolidWorks. It basically allows you to convert your 2D figure into a 3D object by extending the face of that particular 2D sketch. Now see, revolve bossa base is exactly similar to the extruded bossa base, but the name being self-explanatory, it allows you to revolve around a particular axis. So when you're extruding it, it's actually revolving around a particular axis. So if you have to like make a wheel or a cylinder, sphere, or pulley, you use revolve bossa base. The last one is the sweep bossa base. So this one is similar to the above one, which is a revolve bossa base. But the difference between both of them here is that you have the ability to define the particular direction in which the extrusion will take place. So here you actually define a particular path instead of manually doing, selecting all the axes and stuff. Right, now let's move on to the SolidWorks software itself. So first explaining how extrude bossa base actually looks like. I've already made a rectangle here with width 60 millimeters and length 100 millimeters. So what I'll do is I am already in the SolidWorks feature toolbar and I'll select extrude bossa base. Now look, here an already made preview is selected by SolidWorks software, and the fundamental or the pre-made, pre-selected length is always 10 millimeters. So here, let's go ahead and just click on OK, and now you have a solid cuboid, right? So this was your extrude bossa base. Now, let's place Control Z and let's go on to revolve bossa base. So in revolve bossa base, what I'll actually do here is I'll just click on here, and now I need to first specify my axis of revolution, as you can see here. So let's select this edge as my axis of revolution. And now you can see that there is a whole cylinder made, a preview on the whole cylinder is made. To give you a more clear understanding, let's change this instead of 360 degrees to 270 degrees. There you go. So it's sort of like an inverted Pac-Man shape, but this is what it is. Right. So now let's go on to the swept bossa base or the sweep bossa base. Now I'll tell you about the circular profile because the sketch profile actually requires much more experience. You have to actually draw the particular path. In circular profile, I just need to say, specify my axis, and that would be replicated on all these edges or all the sides of this particular rectangle. Let's go here. And as you can see in the preview itself, that there is a window frame sort of an object already made. I did not specify all of these axes, rather I just specified one. And all the edges connected to that particular edge have been replicated with the same shape itself. Let's click on OK, and there you can see. The cylinder is made on all four sides, and it's not even overlapping. Right, so this was the first slide. Now let's move on to extrude cut or revolved cut and linear pattern. So what extrude cut actually does, it is used to cut out a part of a 3D object. So suppose you make a circle or a rectangle on an already made 3D object. What you can do is you can create a gap sort of thing in that particular shape by just using the extrude cut. Revolved cut is basically the same as extrude cut, the only difference being that it is used to remove the material revolving around an axis. The linear pattern here is a different thing altogether. So what it is actually used to do when you have extruded a particular material, particular shape out of your 3D object, the linear pattern is used to replicate that particular shape which is cut out on the whole object rather than manually making it again and extruding it, cutting it, making it again and cutting it. You have the linear pattern. So there are more patterns like this. There is circular pattern, etc., which are used to do the same thing, but their name makes it self-explanatory. Right. So moving on to the SolidWorks, like the software itself, let's use this particular one. And firstly, I'll do the same thing again. I'll just extrude also base. I'll select this particular edge and I'll click on OK. Now, first things first, you have to first make a sketch. You have to first define what shape do you want, or which you want to cut on the 3D object. So first, I have to specify the plane. So this is a particular plane. Let's draw a circle of any diameter. Does not matter. I'm just showing it to you. Let's click on OK, and let's go to Features and select Extruded Cut. Right. So here, an already made preview is selected. Now, since the basic distance is always 10 millimeters, and the basic feature used is blind, let's select on through all. So what through all actually does it does not ask me for a direction. It does not ask me for the distance. Rather, it just goes through and through the whole 3D object itself, through the whole width, through the whole length. Let's go. Right. So now you can see that there is a gap created on the shape which I already selected. Now let's move on to revolved cut. So now for revolved cut, I have actually pre-made a wheel here. So you guessed like how did I actually make the wheel? I made the wheel by using revolve bossa base, and these two rectangles will be the one about which I would be actually making a groove. So let's see. Let's go to revolved cut, and now you can see that there is a preview which is already made about these particular rectangles, and these are getting replicated over the whole circumference of this particular wheel. And if I select on OK, there you go. So these are the grooves which are created. So this is a very rudimentary sort of a thing which I made on the wheel itself. The revolved cut is actually used to do much more powerful things, which I won't be able to showcase here today. Right, moving on to the last one of this particular slide is the linear pattern. So what you can see here, I have already made a rectangle, extruded it, then created a circle here, and then extruded cut it. Now what I'm going to do is I'm going to pattern this, I'm going to replicate this particular hole over the whole, like this cuboid about this particular axis. So if I select this, right, so now this is the most fundamental mistakes which anyone does while going for linear pattern. You have to keep in mind what is going on in the left tab here. So as you can see, instead of selecting features or faces, I have selected the direction. So I have to just delete the direction from here because this is not the direction. This is the feature which I want to actually replicate. Let's go to click on features and faces. Let's click here. And now you can see that this particular object or this particular entity will be replicated. So now I have to go in direction one and I have to specify the direction, right? So now this is going out of the object. So what I can do here is I can click on this, and this actually means that I'm reversing the direction of the replication. Now, if I want more instances, I can say, all right, I want 6 instances. It will make 6 holes. If I want, let's say, more spacing between all the holes, I can, or less spacing, I can go for more spacing. I can do like 12 millimeters, and you can see that there is that they are shifted farther away from each other. But you can see that this particular one is going out. So let's just call this 10 millimeters itself. There you go. And now what I'll do is just click on OK, and there you can see. Instead of manually going ahead and creating each and every shape and extruding cut it, rather I am only going for the linear pattern. So this is actually automation of your own processes. Now the last one which I can do, which I'll show you actually, is the mirror, fillet, and chamfer. So the mirror actually is used to make is used both for 2D sketches and 3D objects. Right now, I'll be showing you the 2D sketch one. The 3D object one is is perfectly the same. Rather, it's only used for a 3D object. Fillet and chamfer, on the other hand, are only edge-oriented features. So fillet actually rounds that particular edge. You have to specify which edge, and you have to specify the radius of the fillet. The chamfer, on the other hand, does the same thing. Rather, it only creates a smooth plane instead of rounding up that particular edge. Right. So to show mirror, I have already pre-made a rectangle here. I have made a center line. What a center line actually is, a center line is used as a reference line. So no action can be done on this. It can only be used for reference. Now, the line which I actually want to replicate is this particular line, which is drawn here. So I'll just go to sketch. I'll say mirror entities. I'll click on this. Now this comes in entities to mirror. On mirror about, I'll select the center line. And as you can see that there is a particular preview here, and you click on OK, and there you go. So now you can extrude it and do whatever you want. Next, I'll show you the fillet and chamfer. So for that, I would be using this particular object only. Let's go to features and let's select fillet, which is on the features toolbar. Let's select fillet. Now, first things first, you have to first specify how much radius do you want. So since it's not that big an object, I'd just go ahead and say 2 millimeters. Now, I can click on this edge, and as you can see that there is a little preview here, but there are these 4 options. Now, these 4 options are also used for automation. Instead of manually selecting each and every edge altogether, you can just click on this, or you can click on this, or you can click on this. So these are actually the different combinations of edges. Right now, I just want to round up all the 4 edges. So I'll just click here. There is a preview. This items to fillet is automatically populated. Let's go select, and there you go. As you can see, all the edges are rounded up. Now, next what I want to do is I want to chamfer these. Now let's select and Control Z. Right. So chamfer is, on the other hand, used to make a plane out of that particular edge. So let's click on this, and as you can see that there is a preview which is clear from this side, and it actually removes this particular material. So if I select on OK, before that, again here the distance and the angle both are set. So I click on OK, and there you go. Here a particular plane is made instead of rounding up that particular edge. So these 9 features were the basic ones which you would be using when you're starting off with your SolidWorks journey. Next, we come to the more advanced features which you would be using to refine your drawing or use more complex features. So these features would be explained by Ashu. Ashu, it's all yours.
Okay, thank you, Rishi. So now let's move on to the advanced feature of SolidWorks. We have 3 advanced features. First one is surface modeling. Second one is sheet metal. Third one is assembly. And we will learn it one by one. Okay, so surface modeling or surfacing in SolidWorks or any CAD software for that matter is used to give a smooth surface to a body like the hood of a car or the body of a mouse. So they basically design the skin of the object and are mostly used for the curved surfaces. On the other hand, SolidWorks allow you to make sheet metal in a fast manner by providing a separate feature for it instead of doing the whole cumbersome process. Sheet metal being an integral part of many electronic items like cases of CPU, etc., and it requires special attention. Moving on, now we start with the important part of any SolidWorks file, the assembly. Here we basically combine all the parts by putting certain restrictions on the movement, both lateral and rotational. Now, in the next slide, I will tell you about the mate. So, what is mate? Mate reference specify one or more entities of a component to use for automatic mating. Like when you drag a component with a mate reference into an assembly, the SolidWorks software try to find other combination of the same mate reference name and mate type. Standard mates include like angle mate, coincident mate, concentric mate, distance mate, log mate, parallel, perpendicular, and tangents mate. And even you can add an angle mate between the combination shown below. In the next slide, I will tell you about the what is mechanical mate. So mechanical mate include cam follower, gear, hinge, rack and pinion, screw slot, and universal joint mate. A cam follower mate is a type of tangent or coincident mate. It allows you to mate a cylinder, plane, or point to a series of tangent extruded faces, such as you would find on a cam. And next, huh. Last one is a drawing. So, like if you have any part and you want to see the front view, top view, side view, or the isometric view, then you can see it by the help of a drawing feature. And also, all the dimensions and the important relations are always listed in the drawing for references. Okay.
Right, so
Thank you.
that was it for the boring presentation. Now we'll be moving on to the live model. If before that, if anybody has any questions, please shoot up. You can turn on your mic, you can turn on your camera, whatever, and you can ask us what questions you have. Anyone? Right. So Kamal Singh and Zubair Ahmed Khan, yes, you can get the presentation. We would be, if you want, we can share it. You can contact me. My number would be there on the IEEE, my IEEE, the group, WhatsApp group. It was like, yeah, we'll be moving on to the live model, which would be a much more interesting experience for you all. Right. So first of all, this is the attendance link. You can fill this in for the certification.
हेलो भैया
हाँ हाँ प्लीज
हाँ भैया तो सॉलिड वर्क मैं थोड़ा बाद में आया था ज्वाइन किया था तो बेसिकली सॉलिड वर्क्स कोई 3D मॉडलिंग सॉफ्टवेयर टाइप है
हाँ हाँ
ओके
तो लाइक इसके और भी कंपेटिटर्स हैं यू हैव कैटिया यू हैव फ्यूजन 360 यू हैव इन्वेंटर यू हैव ऑटोकैड ये सारे भी यूज होते हैं बट सॉलिडवर्क्स इज मोर इंडस्ट्रियलाइज्ड तो उस इट इज मोर यूज इन द इंडस्ट्रियल पार्ट तो इसके जो फीचर्स जो हैं ये ज्यादा रिफाइंड है तो
फ्यूजन
इसलिए
360
सॉलिडवर्क्स
से
इज अ
अच्छा
मच
है ये
सॉरी
फ्यूजन 360 से अच्छा है ये
हाँ लाइक फ्यूजन 360 इज यूज जब आप बिल्कुल बिगिनर्स के लिए यूज होता है कि उसमें इतने ज्यादा डिफाइंड फीचर्स नहीं है सॉलिड वर्क्स में आपके पास मोशन एनालिसिस ये सब बहुत कुछ होता है सो यू कैन एक्चुअली create much more out of a particular drawing rather than Fusion 360.
ओके
Right. So has everyone filled the form itself? Form भर दो, I'll give you 5 minutes and after that, yeah, just fill in the form and I'll get right back to you. Right, so let's move on to the live model. Yeah, so this is an introductory section session only. the SIGs would be conducted wherein you would get a much more enhanced experience of SolidWorks. So stay tuned for that. Now we'll be moving on to the live model, the more. Right. So now let's begin. So first of all, I'll go with the part. I'll open a new file and I'll go for part. And let's select an OK. Now, first things first, which one must do is select what unit do they have to make that particular assembly or part in. I want to create a gear and a shaft, so I would obviously go for millimeters because you can't make a gear or a shaft in meters. That would be ridiculous. Right, so going into MMGS. Now, the second thing which one must do is define what plane you want to actually begin your part in. So I can select on front plane, top plane, or right plane, but I want to go ahead and do the front plane because I want to make the face of the gear rather than going for the top view. So let's select on front plane and let's select on sketch. Now you can either select sketch from here or you can go to the sketch tab and select sketch from here. When you select a sketch, the orientation of that particular plane would be normal to you. And now you can start your drawing. So first things first, let's draw a circular because we all know that gears are in circular shape. Right. So let's just make a circle. We'll not define the dimensions right now. You can do you can define the dimensions from here. You can define the radius from here. Or what I can do is I can go ahead use smart dimension, select on the edge, and now you can see that the diameter is selected by default. And now I can select what diameter do I actually want. So for the diameter, let's go for 100 millimeters. Let's select on OK. Now, second thing which I want to do is I want to extrude this particular circle into a width so that it's good enough for a gear. So now we'll go to features, and as you all saw that we have to go for the extruded bosso base. Now for the extruded bosso base and for a gear, 10 millimeters is quite less. So let's go ahead and select 40 millimeters, or that would be a tad bit too much. Let's go for 30 millimeters, and this looks okay. So now let's select on OK, and there you can see we have sort of a cylinder here, but we would be performing some operations on here. So we would get a much better idea on how to create grooves in a gear. Now comes the more technical part, right? So now you actually have to select which phase do you want to, how do you want to actually create the grooves. So what you can do is, and you can select a center line because first I want to create a sort of a reference line, and I can select on this edge, and to change the orientation, I can click on the Z axis here, which is the blue one, and this would be oriented towards me. Right. So let's draw a center line cutting the circle in its diameter. Let's select here, and then let's select on escape. So now I have the center line ready for me. Now, the first thing which you always do when you're drawing a sketch is you actually first define the shape rather than going for the dimensions first. So first I'll go and I'll select like the outline of what I actually want to draw, and let's click here and click here and say escape. Now what I actually have done here, I've selected one point on the center line and one point on the edge, because as you have seen on gears, the grooves are created from the edge to the center, to the line which is joining the center and the middle part of the grooves. So what you can do here now is you can now go ahead and go for the smart dimensions. But before that, there is one more important thing which you can actually do. It's not particularly necessary to do it before or afterwards, but I can do it right now. Right. So first I'll define the direction between here and this particular point. Now 18 millimeters is a tad bit too much. Let's go for 8 millimeters, right? Yeah, so 8 millimeters is nice. Next thing which I can do is I can go ahead and select how much length do I actually want from here. Now the length which I want from here is not 9.67 meter. That is also a tad bit too much. Let's go ahead and select, let's say 4 millimeters. Now there is one, this mistake is very common. So what I have actually done here is this is a tad bit too much steep. So I can go here and I can just delete this part and I can make it again. So select this one. Now, since this particular distance and this particular distance is already predefined, I can just select it one from here. And this distance does not make any difference. So we want the grooves, but here I'm not going with the actual dimensions for the grooves because we are not going ahead and like giving it for manufacturing purposes. Now, what I want to do is either I have two options. Either I can make these two lines again and go for the smart dimensions again, or what I can do is I can go for mirror entities. So let's go for mirror entities, right? Let's select this and let's select this. Now in entities to mirror, I have line 2 and line 4. and I want to mirror it about the center line. So this is what the center line is used for. It's used as a reference line always. I've selected here and I've selected this. Now, as you can see, these little squares which have different like figures in them, these actually define the relations. So now since I mirrored them, I can see that this relation defines that these are concentric, these 2 points coincide with each other. Distances will always be equal to this distance. This distance will be equal on both sides. This angle would be equal on both sides. So that's the actual beauty of the mirror entities part, is that you don't need to define the relations manually. So now, if I go ahead and extrude cut it, it actually would be a problem for me because this edge is not an entity on itself. It's just a part of the 3D object. So for that, I would have to use the convert entities option. So for the convert entities option, I would select this particular edge and entities to convert, there is edge one, and let's select on OK. Now, as you can see, the color of this particular face has changed. And now if I go ahead and say extrude cut, then I can define this and this. And now in the preview, you can see that there is one whole entity which I would be using to make the whole group. Now, you can either go for blind. Now, what blind actually does is it lets you specify the distance, how much distance you want to extrude it, or how much distance you want to cut it. So I would go for through all, although it does not make any sense that since 30 millimeter was already pre-selected. Let's go for through all, right? Let's select on OK, and now you can see our first groove is made. But again, I want it over the whole circumference, so I won't be going ahead manually and making it again and again. We'll go for not linear pattern, but click on this drop down and you can see so many different patterns. So I'll go for circular pattern. Now, the features and faces is already pre-selected by the SolidWorks software. What I can actually do is I can either, I'll show it to you how you actually do it. I'll just delete it from here and there is nothing selected up here. So you can see this particular arrow that this actually shows you the whole map of your SolidWorks drawing, how you are actually making it, the steps and everything is shown in this particular map. So on features and faces, I can select this particular cut extrude, and as you can see, this one is selected. Now, let's go back to direction. I have to go ahead and make it on the whole circumference. So I'll just click on the circumference itself. And as you can see with the preview, that all of the grooves are already there. But since it's a very, scarcely populated groups, so I can go ahead and go change the number. I'll say 15, and that's a tad bit much better. Right. And since I want equal spacing, so I'll keep this selected. I don't want instant spacing because this is a gear. Everything is pretty much symmetrical out here. Let's select on OK, and there you go. It's an ugly looking gear, but we'll refine it a bit more. So you can actually see that you have got the grooves, you've got everything. But the next thing we actually want to do is we want to create sort of a slot out here. It's actually used for fitting purposes. But here, since I'm only making one gear, it won't be that much of a use, but I'll show you how to actually make it. So you'll actually go to circle, the same thing over and over again. You select on this particular face, you go ahead and make a slot, make a circle like this. You go for smart dimensions. You select what diameter you want to. Let's go for 60 millimeters. Select OK, features, extruded cut. Since I want a slot, so it would be inwards. But now here comes the thing. I don't want it through and through, right? So I won't be selecting through all, since that you can see that the distance parameter here is cut off. I'll go to blind and I'll say, let's say 5 millimeters. Right, so I want a slot which is depth of 5 millimeters. Let's select on OK. There you go. I have a slot. Now I'll want to replicate the same thing here. So you can actually, I'll do the tedious task. I'll go here, select this, circle, smart dimension, 60 millimeters. And now what you can actually do is I'll go to features, extruded cut. Now the information of the extruded cut of the same features is always taken from the previous feature. So what you can actually see is that instead of 30 millimeters, now the extruded cut is by default at 5 millimeters. And let's have tone OK. Now you can see that I have the slot at both the sides. Now what I want to actually do is I want to create a gap wherein the shaft would fit. So for that, again, I would select sketch. I would go for circle. Go here. Again, make a circle. Then let's go to smart dimensions, and let's define the diameter to be 25 millimeters. It's a bit small because since it's obviously a shaft. Now, what I can actually do is I can just extrude cut it, but that would be the boring part, right? Now, I have to create sort of a groove on the circle itself. So the shaft is not allowed circular motion independently. Rather, it would be, if it's moving in a circular motion, the gear would be moving along with it, right? So let me show you how it's actually done. First of all, the orientation has to be changed, and there you go. So first things first, what I told you, center line always, it's the reference point, but herein I would actually extrude it, extend it a little bit, and let's select an OK. Now let's go to line. Let's go here. And first of all, I'm just selecting the outline. I'm not going for any dimensions right now. And first of all, we'll do the mirror entity since the smart dimensions would also be replicated. Yeah. So let's mirror it about the center line here. Let's click on OK. The preview is already made. Now we define the smart dimensions. Right. Let's go to smart dimension, and I want this particular length to be 8 millimeters. And you can see that both the lines, just changing the length of one line, change the length of both the lines. Now I can go here and I can select this to be 12 millimeters, and as you can see, it actually shrunk up a little bit. Now let's click on OK. And now what we actually want to do is I want to make this whole thing a one separate entity. For that, I will go ahead and use the trim entities function. So for the trim entities function, I can trim this part, I can trim this part, and I can remove the center line since it's of absolutely no use now. Now, when I hover my cursor over this particular entity, you can see that the outline of this whole thing is a single one. It's not divided between two different instances. Right, so now let's click on OK, and let's go for the extruded cut now. Right. So again, I told you that 5 millimeters is taken from the previous extruded cut feature itself. So let's change it through all. And let's click on OK, and there you go. So you have sort of a key slot here, but this is what our what the shape of our like shaft would be. So now the next thing which I must do is I must refine the edges, right? For refining the edges, I can go for fillet, and I would select on this edge. Now, first things first, always define your radius, right? So let's just go exit from here. Let's go to fillet again, and let's go for 2 millimeters, right? Let's click 2 millimeters, and now here I have the options. Now there are 59 edges which I want to actually go ahead and put my fillet on. So doing it manually would be much of a tedious and cumbersome task. So I would just go ahead and click here, and as you can see, the items to fillet is pretty much populated by itself. All 59 edges, all 60 edges rather, because I had selected one before only, so that one was excluded there. Let's select on OK, and there you go. It's kind of a funny looking one because the radius had to be of a much slower radius, but I mean, you got the basic idea of what it actually is. Now, another thing which I've always seen as a pattern in like the gear slots is that I always aim for this particular edge. Right. So chamfer this particular edge, since it's only a 5 millimeter depth. Now here is where your instincts come into play. This is 5 millimeters, so doing a 10 millimeter chamfer would basically create the whole shape as a bogus shape, right? So I can go ahead and do it for a 0.5 millimeter, or rather a 1 millimeter chamfer, and the direction has to be 45 degrees because, well, you like 45 degrees is a much nicer uh, angle for chamfer. Let's go ahead and select this, and as you can see that the chamfer has been created, and this one there is sort of a steep slope now. Now what I should actually do is to create to maintain the symmetry. I would again go here. I would select the chamfer. Sorry, not the fillet. I would go here and select the chamfer. Again, this edge, since the distance was already selected, was already taken from the previous chamfer itself. Let's select OK, and there you go. So guys, this is the gear. This is the basic gear which you would be making when you are starting off. So first things, what you actually make when you're starting off with SolidWorks is actually a nut and a screw, nut and a bolt. Sorry, nut and a bolt. The gear is probably the second thing which you make, but gear is much more exciting, so that's why I made it. Now let's save this one. So this one is done. So let's save it as gear. Next thing which we want to do is we want to make the shaft. Again, we go to new, we go to part, we go to OK. Again, the first thing which everyone has to do is select your unit. Then you have to select your plane. Then you have to start sketching. For sketch, again, the shaft has to be of, it has to be in circular in shape. That's why I select circle. I go here. I select, I make a circle. We go to sketch, smart dimension. We select this. Now, keep in mind the dimensions actually have to be same because then we would have problem in the mating part. So we'll go for 25 millimeters and let's select on OK. Right. So the next thing which we want to actually do is instead of extruding it, we want to make the particular slot. So as you can see, the slot right here, we want to make this slot now. Let's go to the sketch and now let's make the slot. Again, same thing repeated all together. First, make the center line as always. Okay, this is a mistake. Control Z. Center line, since you're actually extending something, so it has to be extended to whatever length you want. Next, you can go for the line. Again, I'm just creating the outline again. Let's select OK. Let's go for mirror entities. We're mirroring both of these. Mirror about this particular center line. Let's click on OK. Oh, okay, never mind. Let's go to smart dimensions. Right. So smart dimensions would be, this would be 8 millimeters. And this, as far as I remember, was 12 millimeters. Now, what we actually want to do is we want to make this one separate entity. Now, for that, we would go to trim entities again. We would trim this and we would trim this. And as you can see, this is one separate entity altogether. Now what we actually want to do is we want to extrude it to a particular length. Now, since it's a shaft, it's usually long, so it will go for 100 millimeters. And let's select OK. Now, you can actually beautify a little bit. It's not really necessary, but just for the sake of it, I'll go and fillet the edge. I'll select this. I'll select all the edges. Which edges? Let's select it manually. This edge, this edge, this edge. Let's go to the other part. This edge, this edge, this edge, and this particular edge. Right. So now what I want to do is I want to set the diameter. Let's set the diameter to be 2 millimeters again. It's a bit too much. Let's go for 1 millimeter. That looks fine. Let's go OK. And you can see that the edges have been rounded up here. So this is the basic shaft. This is the most basic shaft which you would actually come across. Now let's save this. Let's save it as shaft. Let's click on OK. Okay. Now comes the actual part of assembling both of these together. So what you actually want to do is you again want to go for new. Now you want to select assembly. And let's select on OK. Now, since assemblies are a much bigger file, it takes a little more time to open. Now, in the first course of your assembly, the begin assembly is already present there. What I want to do is I don't want to include anything from here. All right, so let's just close it. I'll first go ahead and change my units. Then I'll go for insert components. And now I'll first select my gear. I'll place it right here. Then I'll go for insert components again. I'll place my shaft right here. And that's all. Now what you actually want to do is you want to mate these so they would actually move together. So I want to mate the surface, outer surface of this shaft right here to this part. Now it automatically moves here, but but if I click on OK and I select like this, it's moving, right? It's moving. But what I actually want to do is I want to mate. Now that is what this whole slot was created for, so that the independent motion does not take any place. Let's make this to the inner part, and as you can see, it has rotated about, and now you can see that it's here. Now it will just move in that particular axis only. Now what I want to do is, since there would be other gears on this side of the shaft, I would want to make this particular edge and this edge so that I don't have any space left over right here, rather it is here. Now I can make other gears here also, and it would just keep extending and become a gearbox altogether. Right, so let's select on OK. That was the whole mating thing. Now, when it moves, it does not move, since you can see the selected component is fully defined, it cannot be moved because I haven't selected any axis about which it is allowed to move. Right, so this is a basic assembly. Now, I'll actually show you how a gearbox looks like. So this is what an actual gearbox actually looks like, right? So as you can see that there are shafts, there is a key here, which actually defines, which you can use here for the purpose of reference. You can see that there are ball bearings here, and you can see that there are multiple gears. So what this gearbox actually does, it reduces the speed from this shaft to this shaft. Now comes the motion study part of SolidWorks. Here you can actually see how your component would start moving. So let's click on motion study one. Let's click on rotary motor one. And this is the rotary, this is the motor which I want to like rotate. So I want to rotate this particular shaft. And when I start on and select this, as you can see, the speed of this particular shaft is too high, but this shaft here on the other side, the speed is too slow. Look at this key, it's slow, moving so slow. So this is actually decreasing the speed. The combination of gears is actually decreasing the speed, right? So this is a motion study. Now in the motion study, you can enhance this, and you can select how much time do you want, and I can like go for just a second. I can go for the rotary motor. I can edit features. Right now, this particular shaft is moving at a speed of 300 RPM. I can increase it or decrease it accordingly. And after that, certain calculations are performed to get the perfect outcome. Right. So that was it for the live model. If there are any questions pertaining to the live model, please go ahead and shoot the questions. Right. So I believe that I've explained it so nicely.
Hi
But
Rishi,
no,
I have a question.
please go ahead.
Like in the introductory part, there was a thing like linear pattern.
Yeah.
In that, you selected direction 1. There was another column, direction 2. What does
Yes.
that specify?
Right. So in direction one, what you can actually do. So all right. Let me show it to you. Where it is. Where is it? Right. So direction one, I selected this one. So the direction of that particular hole would move on to the right. So it would be moving on parallel to this particular edge. If on the direction two, I had selected this edge, then it would be replicating over here and here also. So that's
Okay,
just
that
more and
means
more
you're
automation.
making another linear pattern.
Yes, you're just making another linear pattern. That's why there are two different directions provided to you.
Okay, great. Thanks.
Yeah. All right. Use of chamfer. So, all right. So, as you saw, that filter is actually sorry, filter, not filter. Fillet is actually used to round up your edges. Chamfer, on the other hand, so now there are many parts wherein you need to fit the object in a certain manner. So, if there is a slant here and you want to select the whole rectangle right here, it won't be fit. It wouldn't fit right. So, you have to create sort of a groove here so that it would perfectly fit. If that explains if that explains the question. Kamal,
हाँ भैया,
हो गया भाई, समझ गया?
अब ये तो प्रैक्टिस करूंगा तभी समझ आएगा पूरा.
अरे नहीं, बस एक चीज समझ लो यार, फिलेट समझ में आया तुम्हें? फिलेट समझ में आया?
हाँ, वो एजेस को राउंड करने के लिए.
ठीक है, चेम्फर सेम चीज है यार. द ओनली थिंग इट डज, वो एक प्लेन स्ट्रेट प्लेन बना देता है इंस्टेड ऑफ राउंडिंग इट अप. और एक चीज समझ लो कि काफी सारे पार्ट्स में डिफरेंट उसे वो चाहिए होता है कि इट नीड्स टू फिट इन अ पर्टिकुलर फैशन, और उसके लिए हम यूज करते हैं चेम्फर.
अच्छा.
ठीक है, जब तुम मोर लाइक जब असेंबलीज बनाओगे और डिफरेंट पार्ट्स को तुम्हें फिट करना होगा, लाइक मेट करना होगा उन्हें ढंग से, दैट इज द पॉइंट इन टाइम व्हेन यू विल एक्चुअली नो कि ये कैसे होगा. Approximately how much time would it take to master SolidWorks from scratch? यार देखो, what happened with me is actually this gearbox which I just showed to you, it was my first SolidWorks assembly. तो ये मैंने लाइक रेफरेंस ले लेके किया था, और इसमें pretty much everything was included. So once you actually start making it, उसके बाद मैंने लाइक अब मेरा since I'm from mechanical, तो मेरे 2 बार courses भी SolidWorks को थे. So I first made that, and after that those features got repeated again and again and again. So that just increased my practice, and इसकी वजह से आज मेरे को ये सारे features याद है. How much time would it take to master? यार master SolidWorks अभी मैंने भी नहीं किया. ठीक है, I'm still not a master of SolidWorks, but I know it to a decent level कि मैं चीजें बना सकता हूँ. That's it. Humble है सर बहुत. जतिन सर आपसे ही सीखा है. हाँ जी. Right. So if anybody has any other questions, please go ahead. अगर नहीं है तो I would like to कोई नहीं कोई नहीं। तो अगर नहीं है so let's I'll call upon Sakshi ma'am. So she's a third year engineering physics student, and she has been a part of IEEE. So she would be going ahead and telling you about the membership process and about IEEE itself. हाँ, sure. All right. Let's start the code. Just give me 5 minutes, guys. I'll be right back to you. I'll get right back to you. Right, sorry. So guys, the game pin is 529 5141. We would be starting on 1 or 102. So please join in. Right, so 10 people, there are 21 people in the crowd, so you all just wanted to attend the session and not go ahead for the prices, I take it? And I see that someone has joined from my name itself. Nice. All right, guys, so we're starting off. Right, so what is the full form of CAD? Basic question, very basic question. It's computer-aided drawing, computer-aided design, CATs are dumb, or computer-assisted drawing? Which one do you actually want to go for? All right, computer-aided design. The person who just selected cats are dumb, please contact me later. I really want to talk to you. Let's go ahead. Okay, so Chinmay at the top. Which of the following is not a part of Autodesk? It's a pretty easy question. Just notice the pattern. Right, guys. So 5 people had said, okay. So you did not like get the pattern that FAI both are like in the same format, but Creo PTC has a different format altogether. Let's go for next. Right. So Chinmay still on top. When was the first product of SolidWorks released? Let's see how much people actually paid attention to the presentation. Seven answers. I know you all are Googling when was the first product of SolidWorks released. I know that. So, right. So 5 people said 1995. That's perfectly correct. Let's go for next. Right. Kamal has a nice streak. Chinmay still on top, 1807. Which of the following is not used to modify an existing shape, rather to add material to it? So extrude or anything like that, just go ahead and go for it. You can actually go ahead and go with the name. You can see which, I just want to check how intuitive your answers are. Right, so 3 people only selected rib. So draft was not the correct answer. Draft is used to modify the existing 3D shape. Only rib adds material to it. Next. Right, Rajat Sharda with a nice streak. Let's go. Highest answer streak of 3. Okay. What do we use to make a replica of sketch entity in the same plane or another coordinate? Right. So I showed it to you. I used mirror entities. I used many things, but there are. Go ahead and answer it. I won't be giving too many clues. Nice. 5 people go for mirror entities. You all were not listening when I was making the live model. I know that. Let's go. Okay, next one. Right. So Rajat Sharda on the top. Answer streak of 4. Nice. 3, 6, 5, 6. Let's go. The extrude direction is always normal to the sketch plane. Believe me, you don't want to get this wrong. Well, remember what's at stake. Remember what's at stake. You would get like swags, and you would get like I came first in the SolidWorks SIT. Let's go false. 4 people said false. Rajat Sharda streak is gone. Never mind. Rishi, I'm coming off to the second place. I didn't even know that. What will you use for this mate? It's either mechanical mate or standard mate. Notice what was there on the mechanical mate's presentation slide. It is a gear to gear mate. Now, will it be a standard or a mechanical mate? Mechanical. 5 each. Okay, 50-50. Never mind. Let's go next. Okay, so Rajat Sharda still on top. I'm still second. I didn't even know that. Let's go. 8th question. 3 more questions left. Which of the following is not a mechanical mate? Cam, screw, pivot, or hinge? Guys, you have to get this right. Go ahead and notice the names. It was there on the presentation slide also. Nice. So 6 people said cam. That was the first mechanical mate, yeah. You have to know that. The cam is the first mechanical mate. All right. So Rajat Sharda with a streak of 5108. You were really listening in the presentation. That's good. Next. Which of the following is not used to replicate an existing feature in a 3D object? Okay, so this is the question. Linear, draft, circular, or mirror? Which one? This is an easy. I talked about this like 100 times in the presentation and in the live model. So it's not used for replication. Not used for replication. Graph pattern. 6 people got it correct. Well, good to know. Next one. Okay, so Raj Sharda, not so much. Never mind. Let's go next. Last question, 10 of 10. Which feature is used to make this geometry? This is a picture question. We are focusing in on the screw. So is it revolved cut? Is it thread? Is it circular pattern or is it mirror? This you should know beforehand before you even started SolidWorks. This is actually a special feature used for this purpose only. Thread. Nice. 5 people got it correct. Next. Right. Now let's see the podium who got now third place, 5 out of 10. Zubair, congratulations. Second place, 4346, Rishi, 6 out of 10. And the first place goes to 7 out of 10, 51701, Rajat Sharda. Great. Congratulations to all the winners and the runners-up, Chinmay, and I couldn't see the fifth place. Sorry, I'm really sorry. But Rajat Sharda, Rishi, and Zubair, very heartily congratulations to you all. Right, guys. So this was it for today. You're all welcome for any questions which you have in mind. The screenshot has to be go ahead and go to the admins. And that's all. All right. Thank you all very much. Thank you all for joining. It has been a pleasure. Cheers.